regression analysis, first of all, we have to understand what is regression. So in regression analysis, we deal with a type of relationship that exists between a dependent variable and one or more independent variables. So when you talk about relationship, how do you understand that? Say here I have taken two variables, x and y, and a set of observations on these two variables, and I have plotted the scatter diagram. And at the center, I have given a line to show the trend. So in this sketch, when I move 1 unit on x-axis, correspondingly half unit change is there in the y-axis. This is what I have shown on the sketch. Take another one. Here x and z, another variable. A scatter diagram is there, and the line to show the trend is also given. And here 1 unit change in x results in 3 unit changes in z. So now the type of relationship that exists between x and y is different from type of relationship that exists between x and z. So in the first sketch, the slope of the line is less, whereas in the second sketch, the slope of the line is more. It is more steep. So regression analysis basically deals with this study. What is the slope of the line that narrates the relationship? Because it has its implications. I will come back to that later. Now, what is the difference between correlation and regression? So in correlation, we deal with the strength of association between two variables. Means how close these points are coming to the line. If all the points fall on the straight line, we get correlation coefficient +1. When some points move away, the correlation coefficient decreases. So in correlation, we are bothered how close the points are to the line. Whereas here in regression, we are bothered about the slope of the line. Establish a relationship. It is possible to predict the value of the dependent variable given the value of the independent variable. Say, for example, here, this line establishes the relationship, and for x is equal to 3, what is the value of z? We can come here, I get this one. What is the value? 1, 2, 3, 4, 5. So the value of z is 5. So for given x, we can predict the value of z. Now again, regression has different subtypes. So first thing, simple regression, it has one dependent variable and one independent variable. So this is the independent variable x, this is the dependent variable y, and therefore the dependent variable is shown as a function of independent variable. So only two variables, dependent and independent variables. So this is called simple regression. Now, multiple regression, one dependent variable and more than one independent variable. Say here, you can look at this sketch. N variables are there, all are independent variables. And y is the dependent variable. So y is given as a function of independent variables. So this is called multiple regression, but the study of this will be more complicated. So we have not included it in our syllabus. Still, we go back to the simple regression. So here, again, there are two subtypes. First one is a linear regression, where there is one y value and one x value connected to the linear equation. Means here the scatter will be in the form of a line only. The line can describe that. Whereas in the other one, non-linear regression, Curves depicts the relationship. One example, curve can be many types. So one particular example I have given here, y is equal to a plus bx plus cx squared. Line of regression. Say, given a set of observations on two variables, it is always possible to draw a scatter diagram and draw a line to represent the relationship between them. Just like what we have been doing, the scatter diagram is that we can put a line and we can predict the value of one particular x, predict the value of y for any given x. Suppose x is equal to 3. What is the value of y? We can put a line like this and a horizontal line like this. So y is equal to 5. We give the answer. But this has a problem. What's the problem? This procedure objective. Okay, now say here I said this procedure of drawing the line manually is subjective. Means what? Different people, when you draw the line, different lines may draw. Say for example, another person may not draw the line like this. He may say that my line will be like this only because this is more representative. In that case, what happens? His projection will go up to meet that line and the vertical line will come like this. So his prediction will be different from my prediction. So there is a difference. So this is what I mean by subjectivity. So to overcome this difficulty, we will use mathematical procedure because mathematics has standard procedures which will not give way to subjectivity. So that's what I have written as the last point. To overcome this difficulty, we can use mathematics to obtain the line of regression. Now we'll come to this line of regression. So let x be the independent variable and y be the dependent variable. Then you can write y as a function of x. So if since further we are assuming it is linear, the functional form will be y is equal to a plus bx. So if you go to the graphical way, the line will be like this, y is equal to a plus bx. Say this form y is equal to a plus bx was taught to you in your school by your teacher. Okay, I hope you will remember. So in this one, what is this a and what is this b? Does anyone know? If you know, you unmute your mic and speak. You don't know what is a and what is b. Okay, so now regarding a is called y-intercept. Means what? When b is equal to, when x is equal to 0, bx will be 0. Okay, so y will be equal to a. That means at x is equal to 0, height of this one will be a. So this is a. So this is called y-intercept, where the line cuts the y-axis. Okay, and second thing, b is called the slope. What is slope of a line? I will explain what is b. Say here, I'll consider a difference of 1 unit. And this 1 unit difference, how much difference it is creating in y. See, 1 unit difference in x, how much of difference it creates in y. This is what I want to check. So that is, this difference is called b, the slope. So in short, what is slope? Amount of change in y for unit change in x. Amount of change in y for unit change in x. So that is a slope. So this is the setup in which we will work. So, but how to calculate this a and b? There are formula already derived available. We will not go into the derivation of that because we are learning statistics as an applied science. So we will learn only the formula and we will learn how to apply. So we will come to this formula. So B we have to calculate first. So B is covariance between X and Y divided by sigma X square. See, this formula is somewhat similar to correlation coefficient formula. So in correlation coefficient, we had covariance between XY divided by sigma X into sigma Y. Remember? So here, slightly different, covariance between XY divided by sigma X square. Sigma Y is not there. So the expanded formula is given here as it was given earlier. And for A hat formula is this: Y bar minus B hat times X bar. So once A and B are estimated, the line is fully specified and it can be used to estimate the value of Y for given value of X. So using this formula, we have to calculate A and B. Once you get A and B, Y is equal to A plus BX is the line. So the line is fully specified. Am I clear here? Can I proceed?
Yes, sir.
Okay,
Yes,
okay.
sir.
Okay, I'll proceed. Now, let us understand B further. Say case 1 unit of change in X I am considering. Here, half unit change in Y happened. So B is equal to 0.5. Okay, that means thus the impact of X on Y is small. Take another example. Here, 1 unit of change in X. See how many units of change? 1, 2, 3. So B is equal to 3. So impact of X on Y is much bigger. Say these have practical implications. I'm going to give you examples. So first example is this one. Suppose a government is planning to spend some 1 crore rupee on literacy improvement. But if after spending 1 crore rupee on literacy improvement, if that literacy will improve only say 0.5%, that is not a good deal. If I spend 1 crore rupee, if literacy increases by 5%, okay, that is a good deal. So this sort of analysis is possible. From the field of environment, I can give another example. See the amount spent on cleanliness drive, Swachh Bharat Abhiyan or anything like that. If I spend 1 crore, what is the improvement in air quality? Is it a fractional thing or is it in big numbers? This is a question people ask. If it is in big numbers, okay, it is welcome move. So this sort of analysis is always possible through regression technique. Now, before you apply this, there are certain assumptions about this model. First assumption is this: the relationship is linear. It is very easy to understand. Given 2 variables and the data, you plot the scatter diagram. If a line can describe that spread, it is linear. If a line cannot describe that spread, it is non-linear. Second, errors are normally distributed. I'll explain this one. Say, consider the case here. The scatter diagram is there, okay? And here there's a point. So for that X value, corresponding Y value is this. But I have put this line of regression like this. According to that, for this X value, the predicted value of Y is this one. Observed value of Y is this one. The difference between the observed and the predicted is the error. So likewise, every point, so of course, for this point which I am showing, there is no error. observed and predicted as same. This point observed and predicted as same. But for all other points, some error is there. So that errors which we measure, and if you create a frequency table, then a frequency curve. That curve, if it is bell-shaped and symmetric about mean, then it is called normally distributed. So this one condition, it should be normally distributed. And third assumption is this homoscedasticity of errors. What is this? In simple words, it means equal variance around the line. So here, equal variance means, see, this is the line, the variance is more or less same spread. Look at the another picture. See, here variance is less from the line. When you come to this end, variance is much more. Okay, so if this is the case, we cannot apply that technique. If this is the case, we can apply this technique. And lastly, independence of observation means there shouldn't be a dependency within the observations. Okay, these are the basic assumptions, and these have to be verified before you apply linear regression. Now we will calculate one regression. We will obtain a line of regression. So exercise 1, obtain the line of regression of marks on attendance from the data given below. Predict the value of the marks for attendance is equal to 6. So here, say attendance is more, marks also may be more. So there may be a relationship between that. Assuming that, we will find what is that line of regression. But usually exercise 1, I used to do it on the blackboard, but today I don't have the blackboard. So exercise 2, which is already available on the PowerPoint, I will be doing. So this handout, I will put it in the group, a PDF file you can download, and later you can solve this problem. Now at present, I'm going to solve exercise 2. Obtain the line of regression of y on x from the data given below and predict the value of y for x is equal to 7. So here the x value is 5, 10, 8, 3, and 1. Similarly, y also given. So I will move to the next slide to show the answer. So while writing the answer, you should write like this. Let y is equal to a plus bx be the line of regression. Estimate a and b. To estimate a and b, we proceed as follows. Now this is our formula for b, and I will create a table here. See, x value is 5, 10, 8, 3, 1, and y, whatever was given there, I have written here. Now look at this formula. Are you following? Please, somebody answer. Hello?
Yes, sir.
Okay. And now, see, the formula says 1 by n sigma xi ya minus x bar y bar whole divided by 1 by n sigma xi square minus x bar square. So here, how we have to calculate? First, get the total of xi and divided by 1, 2, 3, 4, 5. 5 n is 5. So divide by 5, you get x bar. Then this total divide by 5 y bar. And xi into yi you calculate, total is here. That will be divided by n. Then we can subtract this. Similarly, this one, to calculate this sigma xi square, I have created the last column. So now let us do the calculation. So the total of this one is 27. Total of y is 27. And xi into 5 into 4, 20. 10 into 11, 110. 8 into 9, 72. 3 into 2, 6. 1 into 1, 1. And its total. Okay. Similarly, yi square. 5 square, 25. 10 square, 100. 8 square, 64. 3 square, 9. 1 square, 1. And the total here. Okay. Now, let us first calculate x bar and y bar. So x bar is this total of xi 27 divided by 5 observations, 5, so 5.4. Similarly, total of y is 27 divided by 5, 5.4. Now I'm going to substitute in this formula. So this is n is 5, I have substituted. This is sigma xi yi. Some xi yi are here. Its sum sigma is 209. The 209 is written here. Here x bar 5.4, y bar 5.4, and 1 by 5 into the sigma xi square 199 and 5.4 square. This on simplifying 209 by 5 41.8. 5.4 into 5.4 29.16. 199 by 5 39.8. 5.4 square 29.16. Further solving, I get this ratio. Finally, it is 1.187. So after that, I have to calculate a hat. The formula given was y bar minus b hat times x bar. So that is 5.4 is y bar, 5.4 is x bar, and this 1.187 is b hat. So they are substituted, and finally I get the answer. A is minus 1.01. See, I have got A and B, but this is not the answer expected. What is the question? Get the line of regression. So I have to write my answer like this. Hence, the line of regression is y is equal to minus 1.01 plus 1.187 times x. So one more question was there. For x is equal to 7, what is the value of y? So the line what I got here is y is equal to minus 1.01 plus 1.187 times x. So this one I have copied it here. So when x is equal to 7, I can substitute that x here. Y will be this one. In place of x, I have put 7. I can calculate, and the answer is 7.299. Okay. Now, 2 extra questions are there. In the PDF file, you will get all these questions. And for that, I have already given the answer also. You solve that and check whether you are getting the same answer. Okay. So now I have to move to the next section now. 2 lines of regression. Given 2 variables, we may choose either of them as independent and the other as dependent. Thus, we get 2 lines of regression. So out of x and y, you can take one as independent, other as dependent. So 2 choices, 2 lines of regression. So how, first one, we have already done this one. Here what we have done, y was a dependent variable, x was a independent variable. So that's what is written here. X is independent, y is dependent. And we use this formula, we did the calculations, everything is over. Now there's the other choice. Instead of x as independent, here y is taken as independent. Instead of y as dependent, here x is taken as dependent. Okay, so in not to confuse between this, for this one I have put in place of a capital A, in place of b capital B. Okay, so we get the next line. To calculate this b hat, see, numerator was a covariance between xy. Denominator was the variance of independent variable. Here x was independent, so sigma x square. Here y is independent, therefore sigma y square. So another formula, you get it. And correspondingly a value is this, corresponding capital A value is this. Okay, so given two sets of observations on two variables, you will be able to get two lines of regression. I will solve one problem on this also. So first exercise, to do it at home. Second one, obtain the two lines of regression between x and y from the table given below. So this is the table. So I will copy it to the next page. And see, please come back here. What all we have to calculate, please remember. To get the two lines, you need x bar, y bar. Then covariance between x, y. So you have to calculate x into y column. And sigma x square. So you have to calculate xi square column. And sigma y square. So you have to get yi square column. So totally 5 columns should be there. One column for xi, second column for yi, third column for xi into yi, fourth column for xi square, fifth column for yi square. So that is what I am going to do for the second question here. So all the 5 columns are shown. So total of the first one is 48. Total of the second one is 36. Then 9 into 5, 45. 5 into 2, 10. 10 into 6, 60. 6 into 4, 7 into 7, 11 into 9, and its total. Now xi square, 9 square, 5 square, 10 square, 6 square, 7 square, 11 square, and its total. yi square, 5 square, 2 square, 6 square, 7 square, 7 square, 9 square, and its total. So now, how many observations are there? 1, 2, 3, 4, 5, 6. So 48 by 6 will give me x bar. 36 by 6 will give me y bar. And now the formula. Covariance between xy is equal to 1 by n sigma xi yi minus x bar into y bar. So 1 by 6. Now sigma xi yi, this is the xi yi column, this is sigma 305. So that 305 by 6 minus x bar into y bar, so minus 8 into 6. So this 305 by 6, I get 50.83. 8 into 6, 48. So this difference is 2.83. Now sigma x square, 1 by n, sigma xi square. These are xi square. The sum is 412. So 412 by 6 minus x bar square. X bar is 8. Its square is 64. So 4.67. Similarly, y bar sigma yi square. Okay, here it is square. I forgot to put it, is a mistake. So the formula is similar, and this 1 by 6 into 244, that comes from the last column. These are yi square. 244 is sigma yi square. So sigma yi square, there I have written 244. And y bar square, y bar is 6. Y bar square will be 6 square. So this 244 by 6, 40.66. 6 square is 36. The difference is 4.66. So now I have got all the required things. See, x bar is there, y bar is there, covariance between xy is there, sigma x square is there, sigma y square is there. So I will calculate it. I have written everything here. I'll calculate them one by one. So y is equal to a plus bx be the line of regression of y on x. See, y on x means what? Y will be on the left side, x will be on the right side. Y will be the dependent, x will be the independent. So this terminology you please remember properly, because in the questions they may ask this on this, then immediately understand that the first variable here should be on the left side, the second variable here should be on the right side. The first is dependent, the second is independent. Okay, now calculate b hat, the covariance between xy by sigma x square. So covariance is 2.83, sigma x square is 4.67. You get the answer. And y bar is y bar, sorry, a hat, y bar minus b hat times x bar. So y bar is 6 minus this b hat is written, x bar is 8 from here. So that works out to be 1.14. So A is 1.14, B is 0.607. So the line is Y is equal to A 1.14 plus B 0.607 times X. Similarly, the next line, X is equal to A plus BY. So B hat will be covariance between XY by sigma X square. That is 2.83 divided by 4.66. 0.607, and a hat is equal to x bar minus b hat times y bar. So x bar is 8 minus this b hat calculated times y bar. Y bar is 6. It is that. Okay, and it works out to be 4.35. So I can write the line x is equal to 4.35 plus 0.607 times y is a line of regression of x on y. So given two variables, we can calculate two lines of regression. Here, most important thing what you have to remember about the questions that is asked in the examination. Say, suppose a question is, obtain the line of regression of expenditure on income. Expenditure on income. That means expenditure is to be treated as a dependent variable, which will be written on the left side. Okay, income as the independent variable, which will come on the right side. Please understand this terminology correctly. Okay, I'll move to the next one. Say exercise 3, exercise 4, you can do at home. It will be there in the PDF file. Okay, and answer also is given for you. So now correlation and regression from bivariate frequency table. So thus far what we have done is x values were given and y values also were given. Okay, and these paired values we have calculated. This is as good as calculation from ordinary set of observations. But when we were dealing with averages and measures of dispersion, we have also studied how to perform the calculations for frequency tables. Okay, so in correlation and regression also, it is possible provided the frequency table is given. So that concept we will deal here. Now, one thing what you have to remember is that the correlation formula is covariance between xy divided by sigma x into sigma y. Regression, that b hat, is covariance between xy by sigma x square. And also you need x bar and y bar. So in short, from the given table, if you calculate x bar, y bar, covariance, sigma x, sigma y, if these 5 things are calculated, you can calculate correlation and the 2 lines of regression also. So fundamental things are these: x bar, y bar, covariance between xy, sigma x and sigma y. So once this is calculated, we can calculate the rest of the things. So here we'll start that study here. Say, obtain the correlation of two lines of regression between X and Y from the table given below. Say here, let us understand this table. This is called a bivariate frequency table. Just assume that X stands for subject X marks and Y stands for subject Y marks. Okay. Now, X, there are 3 values coming. Y, there are 2 values coming. So what does this 3 means? This 3 means there are 3 students who got 1 mark in X and 1 mark in Y. Similarly, what is this 1 meaning? It implies that there is 1 student who got 1 mark in X and 2 marks in Y. And similarly, this 2 implies there are 2 students who got 3 marks in X and 2 marks in Y. Now, if I get the row totals here, say 3 plus 1 is equal to 4. 1 plus 3 is equal to 4. 1 plus 2 is equal to 3. So that shows the frequency of X. So what does this mean? 4 students got 1 mark in subject X. 4 students got 2 marks in subject X. 3 students got 3 marks in subject X. Similarly, if I get column totals, say 3 plus 1 plus 1, 5. 1 plus 3 plus 2, 6. 6 students got 2 marks in Y. 5 students got 1 mark in Y. Now, what is this? This is the grand total. So when you get the total here, it will be 11. Get the total here, it will be 11. 11 students are there. So these are called marginal frequencies, whereas in the gray colored cell, what all are written, they are the joint frequencies. Okay, now I copied that table here. I want to introduce some notations. First notation is this: let X, Y be a pair of values X and Y. And the joint frequency of XY is given by f of XY. For example, this 3, it is f of 1, 1. This 1 is f of 1, 2. This 3 is f of 2, 2. This 1 is f of 3, 1. So that is the notation here. Then f of x, sum over all x values with the marginal frequency of x. That's what we said. Get the row totals, ignore y, add them together, you get the frequency of x. Similarly, g of y is the column totals we get here. And n is the grand total. So that is this 11. And then x bar I can calculate this way. X into f of x I write in the next column. Get the total. That total divided by this total will be x bar. Similarly, I can write another row here. Y into g of y. Here I can write. 2 into 6 I can write here. And get the total here. That total divided by 11 will be y bar. So I can get x bar and y bar. Now what remains is I have to get sigma x, sigma y, and covariance between x and y. For that we proceed further here. So sigma x formula will be this. Sigma y formula will be this one. These are the modification of our earlier formula. And covariance will be x in 1 by n double summation of x into y, f of xy, minus x bar into y bar. Once these 5 entities, x bar, y bar, sigma x, sigma y, and covariance is calculated, we can get 2 lines of regression and correlation. So now this one problem I am giving, 3 values of x, 3 values of y, and these are the joint frequencies. Now, I want to calculate correlation and 2 lines of regression. So I will start the calculation like this. I've copied that same table here, attached 3 columns here, f of x into f of x. Say the total of this divided by total of this will be x bar. And x squared f of x is calculated to get sigma x. Similarly, g of y, the column totals, y into g of y will write here, and that total divided by this total will be y bar. And y square g of y is for sigma y square. So let us start the calculation. First row total 3 plus 2 plus 0. 2 plus 3 plus 1. 1 plus 2 plus 2. Then the grand total also 16. Okay, then we'll do one more thing. X into f of x. 1 into 5. I'll write here. 2 into 6. 3 into 5. It's grand total. So this is 32. Okay. Now x square. 1 square is 1 into 5, 5. 2 square is 4 into 6, 24. 3 square is 9 into 5, and its total. Similarly for y we will do 1. Sorry, first we'll have to get the column totals. 3 plus 2 plus 1. 2 plus 3 plus 2. 1 plus 2. So then 1 into 6 I'm writing here. 2 into 7. 3 into 3. And the total of this I will write here. This is 20, 29. Now 1 square is 1 into 6, 6. 2 square is 4 into 7, 28. 3 square is 9 into 3, 27. The total of this is here. So now what is this one? 74 sigma x square f of x. What is this 32? Sigma x f of x. What is this? N. This one sigma y g of y. This one sigma y square g of y. So first, one more thing. For covariance, we have to calculate double summation of x into y into f of xy. So that calculation I am doing here. So first cell, x value is this 1, y value is 1 into 3. So 1 into 1 into 3. Now here 1 into 2 into 2, 4. Here 1 into 3 into 0. Here 2 into 1 into 2. Here 2 into 2 into 3. Here 3 into 2 into 1. Here 3 into 1 into 1. Here 3 into 2 into 2. Here 3 into 3, 9 into 2, 18. So now we have to add them together. 3 plus 4, 7, plus 0, plus 4, 11, plus 12, 23, 29, 32, plus 30. So that is that total is 62 I have written. Okay. Now x bar will be sum of x f of x divided by sigma f of x. So that is 32. Say sigma x f of x is 32. That is written here. Sigma f of x is 16. That is written here. So x bar is this. Y bar, sigma y g of y by g of sigma g of y. So this y g of y, its sum is 29. Sigma g of y is 16. 29 by 16, 1.181. And now those values which I have calculated, that sum of x into y, f of x, y I have written, x bar I have written, y bar I have written, and these figures which are required for further calculation, I've just copied there. So this is sigma x square f of x. This is sigma y square g of y. So now sigma x 1 by n, sigma x square f of x minus x bar square. 1 by 16 into sigma x square f of x is there, minus x bar square. That on calculation I get 0.79. Sigma y is this one, square root of 1 by n sigma y square g of y. So 1 by 16 into y square g of y, that is 61, that is there. And y bar is this one, 1.81 square. So that works out to be 0.732. And covariance, see this one we have already calculated, 62. That one is, I'm substituting here, n is 16, x bar, y bar. X bar is 2, y bar is this one, that value. So now we have got x bar, y bar, sigma x, sigma y, and covariance. Now we can calculate everything. For our convenience, this x bar, y bar, sigma x, sigma y, and covariance I have written by this side. Same I will copy into the next sheet. So here it is written. So R is equal to covariance between xy divided by sigma x into sigma y. So 0.255 you can see from the table on the left side, and sigma x is this, sigma y is this. I got this. And first line of regression is this, and we had covariance between x by sigma x squared. So from left side I can substitute. Covariance is 0.255, sigma x is 0.79. I get this. A hat y bar minus b hat times x bar. I'm substituting y bar, I'm substituting b, I'm substituting x bar. I get this one. So this is your A, this is your B. So line is y is equal to 0.99 plus 0.41 times x. Now second line, x is equal to A plus capital BY. So B hat will be equal to covariance between x, y. Again from here we'll get it. And divide by sigma y square 0.73 square, 732 square, 0.48. And capital A hat will be x bar minus b hat times y bar. It's equal to 2 minus 0.48 into y bar, that is 1.81. I get this one. So the line of regression is this. So this completes the topic.